The most dangerous bug in SaaS is a forgotten tenant context, and suddenly one customer can see other customers' data. This will probably kill your SaaS, and if you process GDPR data, it could be even worse. Almost 10 years of experience as a software developer taught me how to safely perform tenant scoping in PostgreSQL and reducing the risk of skipping filtering. In this video, I will show you a simple approach to tenant scoping in PostgreSQL. You will get 3 layers: a safe way to build queries, a database connection tenant context, and tests that catch mistakes. Tenant scoping in queries is the most important rule. Every database read and write must be tied to exactly one tenant. This way, tenant A will only see his own data. In most SaaS applications, each table includes a tenant ID column. That value must never be empty. Here is the simplest baseline I recommend. Tenant ID is required in every tenant-owned table. Important indexes include tenant ID. Let's build the first layer. You want a system where the default path is safe and unsafe queries are hard to write. I will show you 2 patterns you can use in real code bases. Pattern A is simple. Use one entry point for database access. That entry point requires a tenant ID parameter. If you do not have a tenant ID, you cannot run the query through the normal path. You can also use event listeners if you are using an object relational mapping. You can add tenant scoping to your queries or throw an exception if the request is missing context. It makes queries safe by default. Pattern B uses a tenant context on database connection. When a request starts, you must set the tenant ID on the connection. Then your queries can read that value. It gives you one place where the tenant ID is set, and you can use row-level security to add checks that reject insecure queries. Pattern A makes safe queries at the backend. Pattern B makes the database aware of the tenant context. Together, they reduce the chance of a forgotten filter and data leaks. How to make sure that our solution works? This is why tests matter. You want one test type that tries to break isolation. It should create 2 tenants. Then it should attempt to read second's data while acting as first. That must always fail. These tests catch the exact class of bugs you fear, and they keep catching them after code refactors. Here is a simple checklist you can use. Tenant ID exists on every tenant-owned table, and it is required. Your normal database access path requires a tenant ID. Every request sets tenant context on the connection. You have cross-tenant tests for critical endpoints. If you do these basics, your system will be safe. Now you know how tenant scoping works, but the bigger question is, what architecture lets ship faster your new SaaS? In my next video, I will explain why most new SaaS applications should start with a shared database and when that is not true.